If you're like me, you love math and chess, and you've probably heard the famous story about the inventor of chess. He was a poor mathematician living in India, and he thought hard and he came up with this idea for the king about a game called chess. And the king was very pleased with the game and said, "How can I reward you?" And the mathematician very humbly said, "Just give me 1 grain of rice for the first square on the board, 2 grains of rice for the second square on the board, 4 grains for the next one, and twice as many, that makes 8 for the next one, and so on, and I'll be satisfied with that." And the king said, "Is that all you want? Such a wonderful game, and this is the only reward you want, a little bit of rice?" The mathematician, who was a very wise man, he said, "Well, some people say that 1 grain of rice is worth more than all the gold in the world." "Is that so?" said the king. "I'll have to think about that." Meanwhile, the king said, "Okay, you can have your wish. I'll give you 1 grain of rice for the first square on the board, 2 grains for the second square. Double that makes 4 grains for the third square, and so on." And then the king went to see his other court mathematician, and that mathematician said, "Well, you've agreed to a very hard bargain there, Mr. King. Do you realize that that is more grains of rice than in your entire kingdom? In fact, let me work it out." And after some weeks of calculating, the mathematician came back, "This is how many grains of rice you'll need." "My goodness," said the king, "that's an awful lot of rice. How did you work that out?" "Well, of course, in those days they didn't have modern notation for mathematics. Nowadays it's an easy calculation. Here's how it goes. It's just 1 plus 2 plus 4 plus, or up to, well, how many terms in this sequence? The first one is just 2 to the power 0. 2 is 2 to the power 1. 4 is 2 to the power 2. The next one would be double that, which is 8, which is 2 to the power 3. Keep going until you have doubled total of 63 times. So the last term will be 2 to the power 63. You can see there's actually 64 terms in this series. 64 powers of 2 added together. And it's what we call a geometric series because each term is formed from the previous one simply by multiplying by 2, like this. So it's a geometric series. Now, how to add that up? This is a very big number, but can we find a shorter way to write this? Well, if you've been studying geometric series recently, you will realize that yes, there is an answer for this, and maybe you'll see it easier if you consider writing this using binary numbers. Okay, remember binary numbers, we use base 2. So in binary, this would just be 1, and 2 in binary is 1 in the second place, and 4 in binary is this, and so on. So you end up with just 64 ones. This is in base 2 notations. Alright, so I don't have time to write all 64, but you can imagine 64 ones, and we're using base 2 notation. So this stands for this one is this one, and so on. Now imagine what happens if you add 1 to that. If you add 1 here, 1 plus 1, of course, in binary makes 1 0, and you have to carry 1 here. That makes another 0, and you carry another 0, and you'll notice you'll end up with just 1 with a whole lot of zeros in base 2 notation. And of course, that's if we add 1 on here. So just imagine for a moment now, we're interested in this total, but it becomes very simple if we add 1 to it, doesn't it? As you've seen using the binary notation. This is just 1 in the 64th place. That's just 2 to the power 64. Okay? And you'll see therefore that this sequence is 2 to the 64 minus 1. So if you add 1 on to that, you get that. But if you want to keep this really equal to this, you would have to write minus 1 there, wouldn't you? So this number, sorry, this has got 64. So we have to be clear that we've got 63 zeros in there, I think, and a 1 at the beginning. Anyway, it's you've perhaps learned in other ways that this is 2 to the power 64 minus 1. Now if you put 2 to the power 64 in your calculator, you probably won't get this, because your calculator only has maybe 8 or 10 or 12, a limited number of digits it can calculate to. But believe me, this is the answer you will get if you sit down and do this calculation. It's actually easier, isn't it, to do this one, which is just 2 multiplied by 2 multiplied by 2 multiplied by 2. Keep doubling. Start with 2 and double it again, till you have 2 to the power 64. So I've indicated with 3 dots here that I want a lot of these 2's. I write down 2 in 64 different places with multipliers in between, multiply it all together, subtract 1, I get this answer. And that's the amount of rice the king was owed because of this deal he made with the inventor. Now I wonder how much rice that really is. Well, would it be more than a ton of rice? I wonder, would it be more than 100 tons? Well, let's try a quick experiment and try and figure out roughly, estimate how much rice that would be. See if we can get my little scale to work here. Yes. Now this is a fairly accurate scale, but 1 grain of rice, it doesn't want to weigh that. 2, 3. It's rather difficult to get the weight of 1 grain of rice with my scales here, but if we put 100 grains of rice on here, maybe we'll get somewhere. It'll take us a while to do that. So let's just stop the film for a while